seasons. By additionally geolocating high-activity areas and open urination or defecation spots, new interventions are pinpointed. Finally, citizen validation surveys authenticate proposals to ensure that public toilets are available when and where people need them.
Shanti commutes to work by bus, switching at 2 points along her 1-hour journey. Heavy rains worsen her trip, but even on her period, stopping to use a restroom isn't an option. Finding a clean toilet requires a 10-minute detour, risking her chance to catch the connecting bus. Last year, Shanti contracted a urinary tract infection, like countless others who hold in their pee. Though public toilets have been built in large numbers under the Swachh Bharat mission, ULBs treat their daily maintenance as an afterthought. Supported by BMGF and USAID, WASH Institute has developed a toolkit to streamline public toilet monitoring. Using this toolkit, states can assess public toilets based on functionality, accessibility, cleanliness, eco-friendliness, and safety. Toilets receive a revisable rating, and a dashboard mechanism allows ULBs to monitor them at scale and plan interventions. Public feedback reinforces this process, making ULBs accountable for clean and functional toilet infrastructure.
ये साल था 2014, जब माननीय प्रधानमंत्री श्री नरेंद्र मोदी जी ने स्वच्छ भारत मिशन शुरू कर महात्मा गांधी के स्वच्छ भारत के सपने को अपनी आंखों से देखा
कि मेरे 125 करोड़ देशवासी भारत माँ के संतान हमारी इस भारत माँ को अब गंदा नहीं रहने देंगे। पूज्य बापू को सपनों को पूरा करने में हम कोताही नहीं बरतेंगे और ये जिम्मेवारी हम सबकी है।
फिर क्या, देश ने आजादी के बाद पहली बार स्वच्छता के उस आंदोलन को देखा जिसमें बच्चे, बूढ़े, जवान और महिलाएं सभी शामिल थे। सड़क का कूड़ा अब उन्हें बोझ सा लगने लगा था। स्वच्छता के स्लोगन सिर्फ दीवारों पर नहीं लिखे गए, बल्कि लोगों के दिलों में उतर गए। इस ऐतिहासिक बदलाव को देश के हर शहर तक पहुंचाया वर्ष 2016 में शुरू हुए स्वच्छ सर्वेक्षण ने।
Kindly rejoin the main conference hall. We are beginning now. In the afternoon session, we move on to session 6, Technology Selection and Treatment Standards. To begin, I first invite our speakers onto the dais. Shri Rajesh Pai, Director, WASH Institute. Shri Praveen Kumar Garg, Director, NMCG. Professor Ashfaq Jafari, Technical Advisor. Dr. S.M. Subhani, MD, NCPE. Dr. Bhala and Shri Sanjay Roth, Rights. I also invite our moderator for today, Dr. V.K. Chaurasya, Advisor, CPHEO, to lead the session.
Thank you very much. And in afternoon session, I welcome each one of you. Many of us have to catch flight in the evening, so we'll try that within time we'll be able to complete all sessions. So in this session, that is the 6th one, Technology Selection and Treatment Standards. This session is very important from the perspective that Mr. Rajesh Pai, he will explain the experience from 14 towns they have studied on grassroots level, that what is actual condition. Uske baad Sri Praveen will be presenting IND and implementation approach. And then I will be presenting in the morning session, as I mentioned, regarding the treatment standards and what ecosystem is required and what we are working. And after that, Professor Ashfaq Jafri and Sri Subhani ji, their NCP has helped us to develop this advisory on type design for STPs. So they will be presenting, and after that multi-story STPs feasibility and also greenhouse solar dryer that our team from RITES, they will be presenting. So this is the agenda for this session. We will be having around 1 hour time maximum, including 15-minute question answer. So we will take maybe 10 minutes, 20 minutes, whatever is there depending on requirement. So I invite Mr. Rajesh Pai to present the case study on used water management. Thank you.
Good afternoon. Namaskar. Yes. We have it here? Okay. We start, sir? So we start? Yes. Okay. So, good afternoon. Namaskar. So I'm going to talk about the experiences of ours on used water management planning across 14 towns from different parts of the country. So in that particularly, I will share information on Chunar. जैसे हमको सबको पता है, when Swachh Bharat Mission 2 launched, actually one of the key mandate was actually to treat all the wastewater. So the untreated wastewater should not go into any type of a water body. So all the wastewater, whatever is town is generating, it is supposed to treat. So with that, actually keeping that as a frame in mind, we tried developing the approach and methodology. So if cities or towns have to actually plan this 100% coverage, actually most preferred solution people always think is a sewer system. But unfortunately, with the resources available, the capacity with the municipality or maybe the smaller towns, it is not at this point of time we are able to implement. But definitely, I think it can be a part of the solution actually, as it has been recommended, at least for the core areas and all. So we definitely have to find a right mix of solution to cover this 100% areas. Because of the land use, as you know, there are different types like the high density area, low density area, newly developing areas, for which we definitely have to find a different solution. So keeping this as a mind, actually one of the very important a point which has been taken into consideration while developing this. And at the same time, as sir was also saying in the morning, quality and uniformity of approach for planning and DPR preparation. If this is there, then actually this guides actually everyone to prepare a standardized document. At the same time, the DPR also comes in one particular quality so that people really can evaluate that also very easily. And it becomes easier for people to prepare also. So considering this, we had prepared around, as I said, out of the 8 towns, so we are not going to talk about all the 8 towns. One of the town called Chunar, which is in Uttar Pradesh, we are going to talk about. So these 8 towns, what you see are from different topography, terrains, environmental sensitivity, population density. It's basically from class 2 to class 6 town, whereas Chunar, what we have chosen. So in order to develop, while working on these 9 towns, we actually have systematically developed also kind of a methodology which is in front of you, which is a process which literally helps you to go step by step. Because one thing is very sure now, if you have to have a proper, sustainable, technically sound wastewater management project, you need to have a comprehensive process actually. So for that reason, we have developed this framework, what you see, which includes data collection, then systematic analysis of the collected data, and based on the analysis, you then develop projects actually, what is feasible, what is not feasible, and then actually you also make an implementation plan based on the resources availability, the environmental sensitivity, and at the same time, any high risk are there in that particular area. So Chunar is a town actually in Uttar Pradesh. It is on the bank of Ganga and also on the bank of Jargu. Also, there are 2 rivers actually. I'll show you the map actually. And with the population of 37,000 during the as per the census 2011. So this is what you see. There's a huge river there, that's Ganga, and the blue color line, whatever you see, is Jargu. So the city is situated in between these two rivers. So it has a high elevation point and low elevation point, and also half of the town has a rocky strata actually. The soil is rocky type. So as I said, as a first part of the process, we did a detailed data collection. And one thing for our surprise, actually, Chunar has almost more than 95% piped water supply. So that was one of the biggest advantage actually the city has in terms of public health risk actually, because they are not relying on the water bodies, neither the groundwater for their water supply. And more than 97% of the people have a septic tank, a proper sealed septic tank, but they don't have a soak pit. So wastewater, whatever has been collected, it has been discharged into the drains actually. Similarly, the grey water also, they don't have any on-site mechanism for disposal. All the wastewater, the grey water, whatever it is generated, it has been discharged into the drains actually. So, and from the desludging, if you see, they desludge at different point of time. Whoever is closer to the river, they have to do it every year. People who are a little bit far, some people have done not even once in 20 years also. So it varies. So the other data point which is very, very important for us was the drain endpoints. If you see, more than 22 drains are flowing in the town actually in different directions. As you see, the red color point actually there actually which shows as a drain endpoints, which means the drain ends in that location. So we have to measure all these 22 drain endpoints, where how much wastewater is flowing into it, what quality of water is flowing into it. For our surprise, what we saw was the quality of water, what is flowing into it, not concentrated at all. We call it as a sewage or a black water or whatever it is. But at the end of the day, if you see on an average, we have only, from BOD point of view, if you see, it is less than 100 actually. In only one of places, it is more than 100. If not, it ranges in the range of 50 to 100 actually. So this is one of the key lessons actually one has to learn, because most of the time in the morning was also, it was said that we are designing it for actually more than 200, 300 BOD actually, which is not required. Yeah, other than that, they had an UWM infrastructure. This was also discussed in the morning. There was one FSTP was available with 10,000 liters capacity per day. And this actually, from the data, different data were collected actually. From that, what we saw was most around out of 3,800 KLD, 3.8 MLD of wastewater generated, 3.74 MLD was actually the water which is discharged into the drains actually, which means we need to take care of that. So which means at this point of time, the main intervention is actually how do you manage the wastewater flowing in the drain. So again, this also helps us to understand what all infrastructures are available with respect to what improvements you may require and what project intervention can be taken up. This helps systematically to lead to the solutioning actually. The next part, once we knew, we also checked actually the risk. So this is one of the very important point actually which I wanted to show you, which also helps you to select either one wants to go with the sewer system or one wants to go with the other decentralized and on-site system. This framework helped us to analyze the risk of UWM practice actually in respective towns. So as we said that in Chunar, more than 95% of the household got a water supply through a pipe. More than 95% of the people who discharge their wastewater from the septic tank into the drain, and the grey water also, more than 98% people discharge into the drains actually, which means the water getting into the ground and getting contaminated and contaminating the water source as very less actually. So considering that, that was one of the key point which has helped us to say that maybe immediately we may not require a sewer system. If we can take care of the wastewater through an IND, the drain-based solution, it will help us. Yeah, any point of time, if we want to talk about the used water management, these are the four types actually of solution. One can find out either a pipe network or the drain-based on-site or a small decentralized system, or maybe the co-treatment of fecal sludge in existing STP, or maybe a proposed STP, and at the same time it's a fecal sludge treatment plant. So we have to see that how these four types of solution can be integrated within the city's problem actually. So that is what was being tried actually with this particular method. So we have conducted the detailed topo survey, which is one of the very important part of the planning process. One should definitely have it actually, which helps you, and especially if you are going with the sewer network, or if you are going with the drain-based network also, this is very essential component. So when we did the survey, actually it was on not only the road survey, with that we did the drain survey. We also identified systematically where the land is available and to what extent it is available. We conducted the survey of that also, and then the water body also. So these four data were collected also in part of the data collection. So once we collected the data, we also then, using the topographic data, we started working on the planning actually, where we also designed it very clearly for a sewer network and checked how much that would cost. Actually, from our intervention, if you would have seen, there was no requirement for a sewer system, but as an exercise, we really wanted to compare if we use a sewer system versus the drain-based system, how much that would cost. For that reason, we designed. But at the same time, as we said that comprehensive planning is required in future for future expansion, because at this point of time with the resources available, we may go only with an IND system, but whatever infrastructure you provide for an IND system on this date, that should be usable in future also. So that was, keeping that in mind, we have designed this. And then actually, yes, these are some of the projects which was identified across these 22 drains, where these were systematically connected. So if you see the map with the shaded area, these are actually where the drains are, which are systematically connected using the IND trunk network actually. The trunk network, what we designed, was part of the sewer network design, what I showed you earlier actually. So tomorrow, if city wants to expand, if they have an additional resource, they could also provide the pipe in this area also. Yeah, wherever then we have provided the STP, there we have considered for the co-treatment. At this point of time, city has an FSTP and their present demand is met, but for future demand, they have to provide a provision within the STP for a co-treatment. Yeah, for the open area, there are many areas within the town which is under developing now, or a fringe area, or maybe area which is under development. There actually we are proposing the decentralized system or a cluster-based system. This has to be very local, site-specific, because we will not be able to pinpoint at this point of time. That need a detailed local survey, and then we say which can be a small decentralized wastewater treatment system, which can be a community-based pits actually, like a leach pit or a soak pit, whatever we are using, or other on-site systems are also been proposed. So overall, if you see, these are the components of different projects actually under the main project. As I said, the first project was a drain-based solution. Under that, we have listed out 6 projects. The first project was actually the real one, where we have pipelines connected to a centralized STP actually. And then all others are a decentralized STP, because there are small drains going here and there with a very small amount of wastewater, which we really didn't wanted to take it to another direction. We wanted to treat it there only. And as a part 2, the community-based interventions like a soak pits and decentralized wastewater management system. So in general, if you see, this is the total cost, whatever has been estimated for this for different interventions. So this is actually as per the unit cost recommended by CPHO. But when we really do the actual tendering, we will know exactly the cost may a little bit vary. Yeah, so along with that, as we said that the planning process is in place, but at the same time, at the end, one also has to need to select the technology actually. So we have created kind of a pool of technology options, like how one of my other panelists also will talk about it, for nature-based system, as well as for on-site system, as well as for the conventional system. For different capacities, the technical options with the detailed design, description, then the cost, the bills of quantity. This has been developed so that the city also can use it. They don't have to develop it from the scratch. They can use it and then see that how it can be adopted for the local situation there. And from the experience, again, as we said, that we have also developed detailed training modules, actually, which are the e-learning modules. Also, we have it, more than 38 for each component. For example, if one wants to learn how to measure the wastewater in the drain, actually, we have developed one module, which is a video-based module, which will help the towns to do that exercise. Likewise, around 38 e-learning modules of different components of the planning process, what I showed, these are available, and we are happy to share that, and it is already available in the website. And other than that, the physical training modules are also available on all these things. Yeah, these are the annexures. For doing each of the exercise, we have an annexures, the tools available, which either a digital tool or maybe a survey-based tool. So this can be used also. Yeah, similar to this, there are other two towns also we did. I'm not going to talk about it. It has been exhibited in the exhibition hall. You may please visit there, actually, where you can get all the information related to the other two towns. Out of the 9 towns, the 4 towns we have exhibited in the exhibition area. I was talking only about one town of Shunar. Yeah, thank you very much. And at the same time, whatever the methodology I have said, we have also developed a small booklet, actually. All of you can use this, which will help you, which will guide you to prepare your used water management plan. We are happy to share with you all. Thank you very much.
Thank you, Rajesh ji. So, morning session may you see one model DPR, something like that, based on analysis from Chhattisgarh. This is another example, and as in the morning session JS mentioned, we will collect all these things on a knowledge platform so that each one of you can get all information at a single point. With this, these training modules and other whatever they have prepared, that also will try to connect and see that you take maximum benefit of it. So thank you, Rajesh ji. Now I request Praveen Kumar ji, Director from NMCG, Ministry of Jal Shakti, to present on IND planning and implementation approach. Please come and share your experience. Thank you.
Good afternoon. Good afternoon, everyone. Can we have the presentation, please? No, it's... Okay. I got little confused because my name is not Praveen Kumar Garg. I'm Dr. Praveen Kumar, that's why. Okay. Thank you, Vijay sir. Thank you, Rajesh, for setting the tone. I think when we were discussing in the morning also, like the IND and STP systems, basically there are 2 different type of perspectives. One is like, okay, complete comprehensive sewerage network and STP systems. And second thing is like, okay, let's go with an IND sewer and treatment of STP capacity. I mean, every system have its own advantages and disadvantages. And now we have like live experience of say maybe when this Ganga Action Plan first phase 1 was started long back in 1985 when we're like our school, like my schooling was not started. So that system came up with the approach of IND and STP, if we still recall. Okay, later on we moved as we moved to NGRBA, National Ganga River Basin Authority, which was implementing the program. We moved to comprehensive sewer network and STP program. And then maybe after NGRBA, when this Namami Gange program was being planned, I think group of secretary at that time discussed, and they said like, okay, let's go for IND and STP system. Okay, so IND and STP system is particularly, maybe there are many people from, there is bigger representations from urban department. So it's not a like urban development or something like that. Okay, many a times we get the claim like, okay, whatever the investment we are making in IND and STP, probably the city is not getting benefited. This could be true to some extent. I don't agree with fully, because even if we discharge our untreated sewage, maybe the city itself is not affected, but downstream everyone is affected, because same water is a source of potable water, raw water, and of course it's the receiving environment. So when we talk about, like, especially in Namami Gange, our perspective is river perspective. Okay, so we are looking entire infrastructure, entire investment from the river side, and I'll just for the paucity of time, like I'll just like to go through quickly. Okay, so this is one slide like which tell about the Namami Gange program. So it's a integrated river rejuvenation mission. So all the infrastructures, all the investment or efforts which are being taken up under Namami Gange program are river centric. And there are four main pillars of that, like continuous flow, pollution abatement, geological and ecological entity river has to maintain, and then the fifth pillar was also added, like Earth Ganga, which was in December 2019. Honorable Prime Minister during second National Ganga Council meeting said, like, okay, okay, everybody knows, like, people are or cities are getting benefited from the river. Okay, but what about the people who are living on the bank of the river? Okay, if they associate themselves with the river, probably will require less attention towards the river. And there is a live example, I mean, most of us like quote the example of Danube River or Rhine or the cities or the restaurants, beautiful restaurants along the river Danube. But just think of okay, simple example, like now we are sitting in Lucknow and Kumbh is coming up. So what the value Prayagraj will have without a river? Okay, and simply like we see Haridwar and Rishikesh, like the entire economy of the town is dependent upon the presence of the river in that particular stretch. So how we can quantify that? How can we associate the peoples living on the bank with the river? So a new component was added, that's called Earth Ganga. As of now, we have roughly around 484 total projects, sanctioned cost of around 40,000 crores. So this is program breakup. And then we said, like, whatever the infrastructure we are creating, okay, the STPs we are creating, we should have a live monitoring of that STPs. Okay, so as of now, we have 321 STPs which we are monitoring, and out of that 171 are being monitored by OCMS. I like to take okay, the rest of the STPs we have already tendered out for the OCMS in 2 phases. Probably by March we are targeting, like, all the STPs of the Ganga Basin are monitored by OCMS, and you can come and see the centralized data at one particular platform. In NMCG, the data of all the basin states, and state level also, probably in the office of the program director, you can go and see, like, all the STPs of the one particular state. Now we are adding one additional para to that. Okay, my colleague sitting on the dais probably understand BOD, COD, but for a layman, okay, how to differentiate, like, whether 5 BOD water is good or 50 COD water is good. So for that, now we are adding another component, sir, which is like okay, real-time feedback of the physical quality through CCTV. So whenever I'll be going to say, okay, the BOD is 10, you can see how 10 BOD water looks like. So that will like adding a so for it will be very easy for every person to understand, like, how STP is operating, and that will also decide in probably setting up standards, the public acceptability of the standards. Okay, for a scientific person, okay, we may justify, like, 100 TSS is fine, but for a layman, 100 TSS water looks turbid. Okay, for his we can say, okay, there is no BOD in this water, but for him, the water is still dirty. So I think that mindset has also been, we are trying to address. Coming to what are the benefits? Okay, I'm saying, like in the beginning, I said, every system has its own merits and demerits, but there are certain advantages. And that's why I think when the group of secretaries decided, were drafting the framework of Namami Gange, they chose IND and STPs. The first is, like, as I said, quick relief, because you require minimum interventions. You have to just tap the drains. Cost effective, probably, I think Rajesh was trying to share the data, like how much it will be the expenditure required if we go for sewerage network. The third is asset utilizations. If we see, I mean, it's not like that in Namami Gange we are not doing sewer network projects. We are doing, like probably we have, I think 40 odd projects which are with sewer network. And this is our experience, okay? The asset utilization is probably 20 to 30%. And even after 4 or 5 years of the STP construction, the asset utilization doesn't improve because of the house service connections and other issues. This is the totally reverse in IND. Probably in day one, you'll get 70% of the asset utilization. Site-specific challenges, of course, like whenever you have to lay the sewer lines, probably in urbanized area, what type of challenges do we face? Okay, and there are certain historical old towns. Probably we don't need sewer network for those towns because if we see the boundary, the road probably is hardly 2 meter, 2.5 meter, and we have like such experience of in some of the towns of UP and in some old towns of West Bengal also. Sure, like Dutch colonies and other at that time. So we do not have a space to lay the network in that areas. Okay, the other thing is prevention of solid waste, because I'm not saying like entire city is solid waste, but whatever floatables and other things which are going through the drains to the river, probably will have a better IND system, so we'll have proper screening and other mechanism. And regulate, the para 6 is like regulatory compliances and public perception, okay? If a drain is outfalling into the river, okay, probably either if there is no TSS, probably there is no issue. But if it has certain TSS content, it has a mild black color, even if it doesn't have BOD, public acceptance will not be there. They'll keep on saying, okay, this nala is still going, whatever are you saying? And same is with regulatory compliances, because nowadays I think with the awareness and other issues, this is again becoming a challenge. And most of us are daily getting orders from honorable NGTs and other courts like, okay, ye nala abhi bhi ja raha hai, what are you doing about this nala? And para number 7, it is a IND system is a part of holistic approach. It's not a holistic approach. I agree with you. It requires synergy. Like in UP we have like the state has done very well. Like, okay, they are taking STPs under Namami Gange scheme, IND sewers under Namami Gange schemes, pumping stations. Of course, pumping stations location will be at the lowest point. And later on they are like through Amrit and through other programs, they are laying sewer network. So slowly they are converting like IND sewer with the sewer network. So it is a part of a holistic approach. This is one case study I thought I'll present, but this is like Haridwar, wherein there were 22 odd drains which were outfalling into the river Ganga. And within 18 months, all 22 INDs were tapped. Okay, STP capacity was created, and there was not a single drain outfalling into the river Ganga. So one problem is solved. Now under the other funding and KFW, they are probably going for the sewer networks and other things. These are as I said, like many of the projects have completed. And so we said like, okay, we are also in 8th year of the program. So what these are the outcomes. We tried to compare the water quality with respect to one particular parameter, BOD, and how it has improved from in all 5 states. This is a brief of that. Now, this is same outcome explained like, okay, compared to 2018, the water quality has improved in all the states. So this is like fixing with one particular parameter is showing how your investments are yielding. This is again, an interpretation of the data. I know I'm running out of the time. Thank you, sir.
Thank you, Dr. Praveen. Very nicely you have explained why IND was taken and its success also. In most of the part of this journey of NMCG and even NGRCB, we have been somewhere associated and in all discussions also. And urban development ka view has always been that, okay, it should be holistic sewer network, STP and all other. But at that time when this group of secretary meeting was taken, they were concerned ki, okay, network, how quickly you can do. You will take time, but river we have to save from pollution. So it is synergy, whatever they are doing with Amrit and other we can do and still we can achieve. And as they mentioned, in important cities they are also laying sewer and rest may we are taking through Amrit and even SBM and other will be taking up through Finance Commission. So thank you Praveenji, thank you for enlightening people. Now I will come to third one, this presentation on standards that has been really creating confusion in deciding that technology and framing DPR and consequent to land and other issues has been there, so that some of the city I find that they have not been able to move forward because of confusion, and somewhere cost has also been going up because technology selection and other. So I will be presenting on this treated standard effluent standards. That will make clear to some extent that how we should go about. Next, please. So in this we will be taking that what are the requirements of used water treatment standards and what is going on around the world standards may and what are cost implications. Those 3-4 points will be taking up so that it is clear. These are some of the gaps remaining. Almost half of the capacity is yet to be created, and that is coming under SBN and Amrut. But the requirement and something is coming from NMCG also, whatever is left. But to what extent and what technology we should use to treat it and to what extent, because the higher the we treat this, higher the end technology, the cost of treatment will go up. As I mentioned, in case of Mumbai, when it was BOD 20, it was costing 10,000 for 1,000 liter, 10,000 crore. When it raised to less than 10 or less, it was 18,000 crore. 8,000 crore immediately jumped between 20 and 10 BOD. So it has cost implication, that is important. That's why we have to consciously take which we can sustain. And keeping this requirement, in spite of their direction, Honorable NGT has been very concentrate, and they have directed Ministry of Housing and Urban Affairs, Jal Shakti and also Environment Forest to look into applicability of standard for urban and rural perspective. And I would like to mention, Mr. Praveen knows, and that such initiative already in the ministry, one meeting held last year in November under chairmanship of secretary, and also additional secretary hold one meeting last month on 25th October on this, and our ministries are deliberating that how to evolve a graded approach that will be suiting villages also, small towns also, big towns also, polluted stretches also. So this discharge standard. And another thing is, when we are telling that we have to go towards circularity, what should be ecosystem, so that whatever we treat, to what extent it will be used to different type of crops, horticulture purposes, and even road application, discharge application, all is different. Everything we treating to very high standard and then using, that is sometimes counterproductive rather than helping. So those aspects we have to see, and keeping this in view, only we examine that what is going around the world. Those things also I will be presenting. But before that, I would like to bring that In 1986, this was the standard that most of you are aware. But after that, the norms that was notified by MOEFCC in 2017, it was telling 20 BOD for metro cities and capital city and 30 for others. But unfortunately, some people went to court and they told that entire environment is, let us say, degrading. So based on that and some other discussion, this 10 BOD and other thing came from NGT. And there was also requirement that MOEFCC should notify within a month, but that was not notified. And again, central ministry went to Honorable Supreme Court through a civil appeal. So this is also one thing where it is going on, because these things often in every case not applicable and practical in the field. That is concerned. Otherwise, everybody want to go to very, very high standard. But what is its need and why it is why we should do to that extent in each and every case? Let us say in case of all coastal area, Mumbai and other, lot of dilution is there because of sea. In that case, if we are treating to 10 BOD, it will be simply wastage of resources. Similarly, whatever we are putting in agricultural use and irrigation, there if we are treating again, it is counterproductive, because all those micronutrients and other things we are taking out and we are wasting energy and other thing in treatment. So this aspect has to be kept in mind. Morning I shown that even in case of NGT also this sort of standards are there. So this confusion I wanted to discuss and clear, so that while framing DPR for a smaller town, there should not be any more confusion. If you see different states, how they are following, these states differently. In the morning also I shown different, somebody is having 30, somebody is having 10, and somebody is having 20. This sort of, I will say, standards are accepted by their state pollution control board. If really BOD 10 and other, whatever NGT has directed has to be there, it is 6 years, 7 years, these all should have been done to less 10 BOD, but that is not there. So iska matlab ki ekdam totally 100 or 10 BOD पे everything designing, that is not fair. Similarly, if you see in case of China and EU के case में European Union, they are temperate climate. We are in subtropical. In our case, all these biodegradable material degrade very fast. Lekin in case of Europe and colder region, it takes long time to degrade that. They are using BOD 25, but in our case it is 10. Even in case of China, only around Beijing in some areas and some core urban area, it is 10, where it is critical stages, some sort of things. Otherwise, most of the area type T, BOD 20 and secondary BOD 30. Even in spite of that, for villages, another set of these standards are there for all their states. So if our, just like our Indian size of population, if China is doing like that and huge population, we have to provide facilities like that. In that case, if you don't judiciously utilize treatment technology and treat to a level, it will result in wastage of technology, wastage of power, and also whatever sometimes nutrients we are importing, urea and other. On one hand, we are importing and giving huge subsidy. On another hand, we are removing those nutrients and throwing in sludge and other things. So these sort of things we have to economize. It is only application of mind, and through a proper ecosystem, it will result in huge saving of fund, and jo challenges we are facing at this moment, that all will be, let us say, resolved to great extent. This is another thing I would like to mention, that if we are removing BOD from 30 to 20, only 4% reduction is there, but 50% our sewage is going untreated. Their BOD is 200, 250. So if at all we are very serious, and anybody is very serious, let us at least provide primary and secondary treatment to all first, and then go for secondary and tertiary. But what is happening, in name of these higher standards where STPs are there, funds are being quickly utilized to upgrade that without giving much benefit, and other places pay it is going untreated. So that aspect should not be there. We have to properly see that untreated sewage is also treated, where gap is more than 50%, and in many cases even higher end technology capacity utilization is also less. So those aspects we have to collectively address and raise also whatever forum required, so that a solution, if not today, 1 year, 2 years, this solution should come. Similarly, if you see cost variation also, if we see huge variation is there here in case of Capex technology-wise, that is also costing a lot based on technology selection. And if you go for tertiary treatment, the cost is per MLD is very, very high, and O&M is also very high. So this is policy also another important thing. Most of these states 13, 12, they are telling that we will be utilizing 60%, 70%, 80% of treated sewage. But the given standard, if it is not conducive to irrigation, not conducive to water discharge, or let us for pond rejuvenation or in seed disposal, then how they will be able to utilize it? It is not possible to utilize all without this proper ecosystem, and whether for agriculture, domestic, or firefighting, or groundwater recharge, these things should be collectively developed and then decided. That will help a lot to this sector and also country. Reuse standard I will be taking from some countries. If you see in Jordan, they require a lot of these things for cooked vegetable parks and playground. BOD they are taking 30, and for fruit tree and other it is 200. Field crops it is taking 300. In case of Palestine also similar differential based on use standards are there. In case of China also vegetable, cereals and other it is less than 40. Cereals cultivated dry farmland 60, and here in case of fiber crop it is 100. But in our case everything is less than 10. So that is one area of concern. Here sometime I would like to highlight. In case of Israel, some people counter ki in case of Israel it is 10, why not go for the stringent one, and why you are suggesting like that. Here, their problem is not the standard. Their problem is drip irrigation. If BOD is high, TSS is high, it get clogged because that is at very low pressure. I discussed with them a lot. They were also having 20, 30 initially when the sprinkler system was there under pressure. But when it comes to drip irrigation, they have to revise because they want to utilize water resources to very judiciously and efficiently. That was the reason. So these are the, these are 1-2 more examples. So Egypt, they have given in great detail what are the different grades and in different cases how to do application. And the suggested quality what we are telling, in case of marine, let us say normal case mein more than 10 lakh city, BOD can be 30, and then cities with less than 30, and in case of 1 to 10 lakh, less than 50, it is for marine. Even additional secretary mentioned don't differentiate, let it be 100 when it is going to put in marine after primary treatment. So these sort of things we can utilize and huge fund can be saved, O&M can be saved. So this is one thing that as I mentioned, whatever NGT suggested, based on that, lot of difference you are seeing. And the actual thing which I discussed with the CPCB and MOEFCC, they are telling that whatever these norms were notified in 2017 by MOEFCC, it was issued by Honorable NGT. After that, they directed to Ministry of Environment, Forest to notify fresh. They didn't notify it. So eventually the standard in force is 1986 one, that is BOD 30. And same thing in NMCG directive that has come in January, there also it is telling that discharge standards should be as per Act. They have not told NGT. So these all areas telling that especially for a smaller city, no confusion, go for this 30 BOD wherever required unless some specific use is there. And parallel we are making effort. If anything come, collectively we will try to resolve, but because there is lack of confusion, we should not be doldrum and delay all such type of project. Thank you very much. Now I request Mr. Asfaq Jafri and Sri Subhani to present an advisory on this statement. Please.
Thank you, sir. Good afternoon, ladies and gentlemen. I am here to present the outcome of a study carried out by NCPE, Hyderabad, in connection with technology selection for small and medium towns. I am thankful to the CPHEO for giving us this opportunity to work on the advisory and for giving us this opportunity to present the outcome. Today, more than ever, Today, more than ever, this topic has become important. What technology has to be selected for STP? Since yesterday, or more specifically today, several speakers have stressed on this aspect about the technology selection. I'm going to present a study that has been conducted by us. Perhaps for the first time, the SBM2, Urban 2, and the Amrut schemes have synergized as far as wastewater sector is concerned. While 500 Amrut towns can go in for wastewater treatment under Amrut 2, all the remaining ULBs, class 2 to class 6, find funding for STPs and wastewater, unused water management under SBM 2. This means we are looking at about 4,500 and above ULBs under SBM 2, which have the opportunity of treating their wastewater, which was not there so far. The selection of a technology has always been a very, very important topic of important discussion amongst the wastewater technology sector professionals. Today we are going to see it, the STP size as per the specifications given by SBM. We are going to design it for 70% of the current population, and then we'll expand it later. That's the current guideline. Now, the present study deals with the objective, as I have listed there, about the nature-based technology versus mechanized technology. In order to choose between these two, we have conducted a life cycle cost analysis to design and undertake estimation of CAPEX and OPEX cost, that is the capital cost and the operation and maintenance cost. We also considered the land cost, because each technology requires different land areas. Combining all these things into a technical economic analysis, we have arrived at a conclusion recommending the type of suitable technology for different land costs, as well as volumes, STP, MLDs. The chosen technologies you can see over there, about 10 technologies have been chosen. About 4 of them are nature-based technologies and their combinations, and another 4 are mechanized technologies. Now, the characteristics for which the design has been done are listed over there. The input consists of latitude, elevation, which is very important as far as nature-based solutions are concerned, that is waste stabilization ponds, facultative ponds. The whole design is based upon the latitude and the altitude. And then the temperature, all the processes are important. Temperature is important in all the processes. And then the peak factor and the influent BOD and COD, a lot of discussion has taken place so far. The effluent BOD we have chosen as 30, but the influent BOD has been kept as 250. What we felt is when we are designing for grey water, for example, the BOD is only 150, no doubt. But when you go for co-treatment, that adds another 50 or odd BOD to that. So that comes to about 200 to 225. In that view, with that view, we have taken 250. And then the effluent standards are, as discussed by Chaudhary just now, we have taken 30 as the BOD and 250 as the COD and so on. These we are not varied. The design components are, we are having common components like wet well, coarse screen, medium screen, grid chamber, secondary settling tank, chlorination tank, and primary settling tank is required only in biotower. Then design bioreactors is done based upon the CPHEO manual, that's the first preference, or the advisories released by CPHEO. If these two do not cover the technology, then we are going for Metcalfe and Eddy, a standard textbook or more or less a Bible for wastewater treatment processes. Now the wet well design, as you can see, we are done for 1 MLD, 2 MLD, and 5 MLD. The diameters, the depth is taken as 6.5 meters head, and the pump size we obtained is 2 kilowatts, 4 kilowatts, and 10 kilowatts for 1, 2, and 5 MLD. Then we designed the coarse screen, fine screen, and the grid chamber. The various dimensions are also there. Then I'm showing you a waste stabilization pond, which consists of a wet well with pump, coarse screen and fine screen chambers, grid chamber, then anaerobic pond, facultative pond, which requires only desludging. There is no aeration required. This is a nature-based process. And then you have the chlorination unit. The references are again the CPHEO manual as well as the IS 5611. This is the basic design, 250 mg per liter BOD in, 2 days HRT for anaerobic pond, BOD out is 127.5. This goes into the facultative pond, 2 primary facultative ponds and 1 secondary facultative pond. If you want, you can also add a maturation pond after that, in which fisheries can be undertaken. This is the size of the various units. This way we are designed. One thing that I would like to point out here is all our designs is based, the area estimates are based upon the actual layouts. We are not taken just the size of the tank, but we have placed all the tanks, we have prepared a layout, and the whole area of the layout has been considered here. So different technologies we are taking. You can see the layouts over there. And this is for the biotower. And then we have the primary clarifier, secondary clarifier, and then chlorination tank and so on. All these designs have been done. Then comes to the cost estimates and basis of costing. The capex we have taken, the cost of the structures, and then electromechanical equipment, including transformer and generator, and the land cost. In OPEX, we have taken establishment, which is nothing but the manpower as per the CPHEO recommendation, and then energy cost, consumables like chlorine and maybe polymers, etc., and then fuel. Then laboratory fuel is for the generator, laboratory cost, analysis cost, then repairs, renewals, etc. The basis of costing is layout of the plant, detailed designs, specifications, latest DSR, market rates when they are not available, and so on. Now for these 10 technologies or combinations, 3 STP capacities, that's 1 MLD, 2 MLD, 5 MLD, and 5 land costs. 0, that means government land is available, you don't pay anything for the land, or 25 lakhs per acre, 50 lakhs per acre, 75 and 100 lakhs per acre. These are the 5 land costs that we have considered. And then we are taken for the life cycle cost analysis, 15-year period. Then energy cost is 8 rupees per kilowatt hour, and 10% per annum is the interest rate, and escalation is also taken as 10%. Then this is the outcome that you see over here. No. Yeah, this table, as you can see over here, this makes a very significant discovery that we found. Waste stabilization pond consisting of anaerobic pond and facultative pond is having the cheapest life cycle cost, or the least life cycle cost, for a capacity of up to 5 MLD and land cost of 25 lakhs per acre. Till that, this emerges as the cheapest life cycle cost technology. Thereafter, for 1 and 2 MLD, beyond 50 lakhs, biotower has emerged as the least life cycle cost. And then for 5 MLD, we are having SBR and other technologies. So for small towns in SBM2, as many speakers have already said, we prefer waste stabilization pond, if area is available. Then we prepared a nomogram. The earlier table was for discrete data 1 to 5 MLD. This nomogram can be used for 1.5 MLD or 2.2 MLD and so on, because it's a continuous graph. Thank you.
Thank you, Professor Jaffrey. This analysis is very, very important in the sense that they have come out that if we are going to purchase a land, then how economics will change. Even if you are purchasing, then still we are finding that we can safely have those nature-based technology which are less mechanized for a smaller town. इसमें another important thing is there that together NCP together with CPHO has developed all these design in Excel sheet. So as Madam mentioned in the morning, the moment we are going to put on knowledge center, all those things we will put so that each and everybody who is interested, by putting only few parameters, they will be able to find out which is economical in their given land cost in given their area, and which way to go in technology selection. So it is going to empower all urban local bodies and engineers in a कह सकते हैं कि very substantive way. Thanks to NCP and thanks to Professor Jaffrey. Now I request Professor Dr. Bhalla to Dr. Bhalla, please come and explain on the multi-story multi-story STP feasibility. See, on one hand, because CPHO is technical body, our job is to provide solution for all sort of problems. One way we are advocating this nature-based and other for smaller ULB, but where there is no land at all available, even we are suggesting you go for multi-story also where land is not there. So this advisory is attempted that where land is not there, how in very minimum land we can make even underground, semi-underground or overground. So Mr. Bhalla is with CPHO. He will be explaining quickly on feasibility of multi-story in different towns. Thank you.
Respected seniors and my dear friends, I'm going to discuss a very innovative, resource conservative and sustainable approach. That is a multi-story sewage treatment plant. Multi-story sewage treatment plant, that is a need of our, that is our circumstantial requirement. In what sense? Due to rapid unplanned urbanization, then comes high population density, then limited land resources, specifically in the metropolitan regions. So we don't have the land for the development of the new STPs and for the retrofitting of the expansion of the existing STPs. So we just have to look into it, the new innovative technologies. We can't dead end the situation. We have to go for new technologies. So this is a new approach, a multi-story sewage treatment plant. We can save our land resources, just like cost saving, lot of cost saving is there. Then comes if we go for, there is two criteria for multi-story. We can go for below the ground and above the ground. If we go below the ground, the upper region, we can use that region to make ecological parks, biodiversity parks. So that is definitely a new approach. This is the landscaping view of a typical conventional STP. And upper region, there is a biodiversity park over the multi-story underground sewage treatment plant. Then comes the objective of the feasibility report. In our mind, there is a doubt regarding the multi-story. There is a myth that whether this process will be feasible, whether we will get desired results. It will be expensive. It will be too expensive in related to conventional technologies. So we have to, we have released a report on regarding the feasibility of this multi-story STPs, particularly on these, to answer these questions. So what is going on? So objectives, to provide the guidance on the feasibility of multi-story STPs. Then comes the, okay. Right. Then comes second is the land area and the cost comparison. Another is the operational performance, whether we are getting the results as per the norms. These are the objectives of the study. This is not a new technology. Already this is an established technology. Number of countries, they have adopted this technology. We have, in India, we have a very few plants of multi-story. One in Rishikesh, another is in Pune cantonment, then at Delhi, and coming up, that is a mega project that is in Dharawai, Maharashtra, Bombay. So,
Can I just adjust your mic? Sir, please step a little closer.
that's okay. So I have just covered a few case studies, scientific case studies. Firstly, that's the older one. That is based on at Osaka, Japan. That study was conducted in 1991. The technology they have used that is ASP, activated sludge process. In that, what they have just proved it out. If they go for conventional single-story STP, the area covered that is 164 square meter. And in case they go for multi-story, one tank over the other, the area get reduced, that is up to 76 meters. So what they have saved, that is the saving of about 46%. Another, this is regarding the land occupancy, then covers the cost comparison. In multi-story STPs, that is lower in what I just proved it, they have proved it out. Main structure in multi-story STPs, main structure cost less, while in single conventional story, the main structure cost more. But for multi-story, they need additional support. They need the retaining walls and earthwork. So that the thing is the two things got equalized. So construction cost is almost equal. So this study proves this. Accordingly, afterwards, I just think it out. I just search out. I search out a treatment plant, STP plant at Maharashtra, Pune, at Pune Cantonment Board. That its capacity is 20 MLD, and to compare it, I just search out a conventional sewage treatment plant based on the same technology, that is SVR. And its capacity is almost same, and I compare the area-wise and the cost comparison. Cost-wise, it's comparatively is marginal difference, and the area-wise, it is almost doubled. So this I just prove it out. Next. Operational performance of multi-stories. From these studies, I got some results. So the results what we are getting, they have got that are under permissible limits. One of this is Osaka, Japan. Another one is a multi-story at Rishikesh, Uttarakhand. So conclusion that ultimately we have to move for a new technology. So that is feasible already. The other countries, they have adopted. So we just have to go for multi-story. We are just facing a dead end, particularly at the metropolitan regions where there are land scarcity is there. Yeah, thank you.
थैंक यू भल्ला जी. इसमें एक मैसेज एक क्लियर है कि द मोमेंट वी गो लेट अस से सिंगल स्टोरी टू डबल स्टोरी ट्रिपल, area reduces and overall cost remaining same, so it effectively saves land. This thing can be taken especially for larger town where technology is high end and footprint is less. It will not be feasible for all those nature based and other technology. So after this, the last one presenter is Sri Sanjay. He will be presenting about greenhouse solar dryer, just the problem we are facing in case of sludge and also even in coming days with compost is that moisture content is high and pathogens are also high, that makes it unfit for use. So he will tell that use of solar dryer, this greenhouse solar dryer, how we can raise temperature to a level so that pathogens get inactivated and that become useful for use and acceptable, more acceptable to users. So please, Mr. Sanjay.
Thank you, sir. Namaskar and good afternoon, everyone. MoHUA is going to release soon advisory on promoting offtake of treated sewage sludge, and this can be achieved through the eradication of pathogens and removal of moisture content of sewage sludge using the solar greenhouse dryer. So first of all, we should know what are the issues with the sewage treatment, sewage sludge. The biggest issue is the high cost of handling and transportation because of the high moisture content. It has health hazard because of the pathogen content, and the conventional sludge drying beds taking longer duration of drying time and less acceptability due to the odor, moisture content and pathogen. So all these issues has been addressed in this advisory to so this is the basic objective of this advisory. So the basic principle of a greenhouse dryer is very simple. That is the evaporation of water from the sewage sludge, and that has been determined using the solar radiation, humidity and temperature. This can be achieved by enhancing due to the increase of area of heat capture. That rate of evaporation can be increased, and also to exhaust the saturated air using the turbo ventilators and vents. The humidity and temperature inside solar greenhouse dryer is monitored and controlled on a real-time basis through the sensor, and the removing humidity and hot air out of the solar greenhouse dryer through the ventilation and exhaust fans. So to achieve this, it is very important to design the solar greenhouse dryer effectively and efficiently. The orientation is also very important. That has to be kept in an east to west direction to absorbing the maximum sunlight. Parabolic shape is also enhancing the transmission of a solar radiation and reduce the wind load. The multi-layer polycarbonate sheets with a UV coated on the both sides also enhance the efficiency of solar radiations and also capture the heat inside for a longer duration. The height of the solar greenhouse dryer shall be kept up to 2.4 to 3 meters at the center point to get the maximum solar radiation and maximum efficiency. And all the greenhouse dryer shall be sealed properly to reduce the thermal losses. And solar PV module is to be installed to operate and to exhaust the fans to determine to operate during the daytime. So we have calculated the tentative area required for the 10 TPD plant. So the sludge height has been assumed as a 30 centimeter, and the temperature has been assumed at considered the 45 degrees centigrade inside the greenhouse dryer. So it is required. For the one thing is also important, that is the eradication of pathogen and moisture content is depend upon the two factors. One is the temperature and another one is the duration, and these both factors are inversely proportional to each other. If the temperature is rises, then the drying time will be reduced and vice versa. So if the inside temperature is about the 70 degrees centigrade, then it will take only 20 minutes to eradicate the pathogens. And if the temperature inside the greenhouse dryer is above 40 degrees centigrade, then it will take 1 week to eradicate the pathogens. As per the US EPA norms, if the temperature is 70 degrees centigrade, then it will require 30 minutes to eradicate the pathogens from the sewage sludge. Then we have calculated the tentative area required for the 10 TPD plant, and we consider the 30 centimeter sludge height inside the drying greenhouse dryer and 45 degree temperature inside it. So it will take us 7 days to take the dry, and that's why you consider 7 plus 1 beds, total 8 beds, and the approximate area required for the 434 square meter, and the approximate cost is to be 52 lakhs. Then operation and maintenance is also very important to get the maximum efficiency of solar greenhouse dryer. So again, the height of the sludge dryer inside the solar greenhouse shall not be exceed 30 centimeter, and the sludge turning shall be done inside the solar greenhouse at least once in 1 to 2 days. and the carrying out this turning and scraping etc. during the early morning or late evening, and also while cleaning the parabolic or polycarbonate sheets at least 2 to 3 times in a month with a water and soft cloth. It never rub when it is dry. So finally, the dried biosolids can be utilized as a soil supplements or soil enhancer because it has a high nutrients and increase the voids ratio in the soil. So it can be, we can get the quality of that dried biosolid as per the EPA specification of class A. So it can be utilized for the gardening purpose and in the agriculture purpose as well. So this advisory is already ready to share with UTs and states to get the suggestions and comments from them to further enhance this advisory. Thank you very much.
Thank you, Sanjay ji. The idea of this advisory came because we come across one CSC study where most of the compost plants and even this fecal, especially sludge, they were not being taken or preferred by people because moisture content was very high, 40%, 50%, and pathogens were also there. So in spite of all treatment, rather than using in field, it was being dumped, and all efforts on treatment was not fetching any fruitful thing. So through this process, one thing we have tried to, you are all aware, in case of compost, if 3 to 4 weeks we keep, temperature ranges between 45 to 55, and that inactivates all pathogens. Here we have studied that this temperature somehow artificially is raised 65 degrees, 70 degrees. The time of, let us say, this the inactivation of pathogen reduced to 1 hour, 2 hours. So it expedited all the process. We are going to release it for comment from the state, and after their valuable suggestions we will improve, and then we will further provide to states for use. So this was our presentations. Now, ma'am, we will take 2-3 questions and then your guidance. Thank you. So we will take 3 questions, maybe 2 to 3 questions. Anybody can raise question, whoever want. Yes, please.
My question is to Mr. Raut. Since you have advocated for the greenhouse dryer, we have already sludge thickener at our plant. We are running SBR technology-based sewage plant at Chandigarh, and we have a sludge thickener machine over there. And so the content, moisture content in the sludge is already considerably lesser as compared to other plants. And then we have a gasification plant also where we induce or we produce the gas out of the remnant sludge over there. So still, will you advocate the use of your technology in such plants?
Yes, because sure, because what happened when we de-sludge or de-water the sludge, the pathogen content cannot be removed, because it requires certain temperature and time to eradicate the pathogens, and that is the important thing to reutilize in anything as an agricultural purpose or any garden. So that will be always, and this solar dryer system is always economical than other methods. So that we can suggest to use the solar drying method. Thank you.
this effort we have taken to, let us say, standardize quality of treated sludge when it goes for, when it is ready for use. So moisture and this pathogen, we will be giving a certain level of surety that moisture will not be beyond this level and there will not be pathogen. It is safe for use. So in spite of that dewatering you are doing and even that biogas you are making, after that also it is advisable that when it is dried further, even sun dry or somewhere else, pass through this dryer so that quality will become uniform. It will just like a process for standardization, I will say like that. This is there. Yes, but pathogen is another thing. I mentioned two things, moisture content and pathogen. No. See that.
आपके पास वो एक ऑप्शन है, अगर 30 डेज के बेड का आपका स्प्रेड है, इतना स्पेस है, तो आप करिए, वो भी करिए, वो भी एक ऑप्शन हो सकता है। ये सब क्विकली करने का एक तरीका बताया था, जहाँ पे समटाइम्स व्हाट हैपेंस कि आपका वेट सीजन है, कोल्ड सीजन है, ये सब नहीं हो सकता, तो ये सब जगह पे एक अच्छा ऑप्शन दिया गया।
Again, as I said, we cannot pick up any of these things out of context. Yesterday also, you had asked a question about biogas plants and community toilets in Chandigarh, right? I think you or your colleague, somebody had asked. It is very common sense when we listen to this, that while this is a feasibility that is being shown, we are not asking you to put it anywhere and everywhere. If you have a fair enough land with a good sludge drying bed, we are certainly not prescribing कि जाके इसको लगाइए. But there are places जहाँ पे humidity high है, drying नहीं हो पाता है, cold climatic conditions है, even organic compost में we also get these things. So this is a possibility to be used where such kind of local conditions arise. Low cost, viable, eco-friendly, but again and again I keep emphasizing whenever I speak to all of you, local conditions को ध्यान में रखें और अपना technology चुनें.
Thank you, ma'am. Any other question? Otherwise, we will request, ma'am. Yes, ma'am.
So, no questions. 30 seconds, all of you, if you could just augment a few things for our audience. फिर से 30-40 seconds में आप wrap up कीजिए. There are, let's say, about 20% of the small cities who are going for standalone FSTPs. For these cities, what are the do's and don'ts that they have to keep in mind? That's the question for you. Praveen ji, the question for you is, you have the longest standing experience of implementing IND with STP in the Ganga Basin. Now there are many colleagues here who are from the non-Ganga Basin. So for them to implement, what is the kind of things, let's say 4-5 things that they have to keep in mind? Drain tapping कैसे करेंगे, correctness कैसे करेंगे, planning का क्या time होगा, implementation के लिए कितना time रखेंगे? Just give them 4-5 points very quickly. Dr. Ashfaq, for you, what I would request you to supplement is, you did mention at the end of your study that you saw the waste stabilization pond and the biotower. Just kindly reiterate for the audience, if they don't have a land, you showed the cost efficacy of waste stabilization pond. That's what your study established. Praveen also kind of indicated as a cost comparison and it in his study. But if they don't have a land, then biotower land requirement क्या है, क्या नहीं, थोड़ा सा उस पे please just respond very quickly. Bhalla Saab, I want you to quickly give again in 30-40 seconds. You actually elaborated a little more of the cases which were outside India. However, your first slide did indicate those 10-12 places, including Rishikesh and all, in India where they have gone for multi-storied STPs. तो multi-story STP का feasibility आपने दिखा दिया, but are you ready? Do you have those 10-12 cases of India where they have done it to be readily shared with them? If so, that link should be shared immediately. So for the 4 of you, your 30-40 seconders start now. Start off with Rajesh ji.
Yes, madam. I think it is a very pertinent question. I would say there are two things which one needs to consider, especially if you design the fecal sludge treatment facility for a smaller town, especially with the 10 to 20,000 population or still lesser. So one is a quantification. Most of the time, I think the quantification is done on 3 different methods actually, and we tend to design it very large. So, and also the method what we use it for the design, which makes it still bigger, because we wanted to keep the safety factor and all those things actually. This not only increases the cost, but also the operation and maintenance also, the requirement of it. So my suggestion would be, we need to be very sensible while quantification of a fecal sludge, looking at the present practice, because in one of the 14-town study, what I was mentioning is some of the septic tanks or pits were not emptied for 10 to 15 years actually. So the biggest challenge as on date, what I see is whenever you do a fecal sludge treatment facility, just I want to take one example of Devanahalli in Karnataka, which was designed in 2015 for 5 KLD of capacity. I think in the last, it is almost now 7 to 8 years. Now it is reaching to that level of capacity actually. So that's the reason it is very crucial that the quantification needs to be done properly. The second thing is the selection of technology. I think most of the time what we do is, again, as sir said, that we try to go for a higher level technology to meet the higher required standards and all. I think we don't require that at this point of time, because the end product can also be like a soil conditioner, and there are different way how it can be also disinfected. One of the method, as mentioned by one of my co-panelists here actually. So nature-based system is more than enough at this point of time. A simple sludge drying bed with the little bit we need to take a care for the monsoon season and all, wherever there is a high rain actually. If not, a simple drying beds are more than enough at this point of time, basically to dry it, and whatever liquid comes, that also can be treated with the simple liquid treatment facility like an anaerobic baffle reactor or a planted gravel filter, something like that. So these are the two things what I would see which is very important as a designer or at a city. Whenever you design, you need to take it into consideration.
Thank you. Praveenji.
Thank you, ma'am. The crux is time. Okay. I mean, when I mentioned we have 40 odd projects with comprehensive sewer network, probably I'll not like to name them from this platform, but those projects probably started maybe 5-6 years back, and we are still struggling to commission the STP and commission the entire sewer network. Probably in these 5-6 years, the city limit has also grown up. And even if we say it is outside the municipal limit or something like that, the pollution will come from that area also. So for an IND scheme, the advantage is time. So ideal time we consider around 15 months. So there are STP constructions 15 to 18 months, and equivalent time is for laying of IND, because you do not have to lay lines very, very long networks. The second thing is we have to think a mix of centralized versus and decentralized. I think Rajesh presented a study wherein okay, there was one centralized solutions, maybe particularly for 4, 5, 6 trains, but it depends on the topography also. We have live examples wherein we had initially thought of going for a centralized system, but during execution it came to know if we go for decentralized for these 2 particular drains, probably we don't require the permissions from local bodies and other things, because I was supposed to lay line of say 3 kilometers for 2 INDs, and now we moved to decentralized STP of say few hundred KLDs. And nowadays, good solutions are available. It's not like that we have to, nature-based solution, perfect if we have land and other things. But if there are space constraints, then up to certain KLD, say 500 KLD, very good model package solutions are available. You can just come plug and play type. Third point, whenever we go for any of the system, probably I think that has already been covered. But co-treatment, okay, irrespective of the town categorizations, there will be certain areas which will be always relying on the septic tank. So what we have adapted, this was also a learning, like it was not earlier with our projects. Later on, we made it as mandatory part of, as co-treatment as mandatory part of the STP, which is not resulting into any particular cost. We had like few of the multi-story STPs. I think one example he quoted. Another is coming up in Lucknow itself. That is also a multi-story STP. Work has just started, and also on the solar drying components also. So one advice is that if we integrate these things together in the project, depending upon the requirement, I'm not saying like it should be done for all the STPs, but do it in the beginning. Like we have live example wherein we are making co-treatment as part of the STP. It is not resulting into additional cost. But if you are adding it later on stage, it will impact, like it have certain high costs. Okay.
Great. Thank you, Dr. Ashfaq.
Thank you, Madam. Madam, the presentation that I made was for the design of waste stabilization pond for a city in central India with an altitude of about 300 meters and average mean low temperature of December as 14.5 degrees centigrade. For that, I obtained an area of about 2.5 acres for one MLD plant. In contrast to this, a biotower plant requires about 0.43 to 0.45 acres of land, which is very much comparable to the land requirement of the MBBR or SBR or even USBR, etc. So in that way, this is going to be much less than that. But compared to these mechanized technologies, the biotower does not require aeration. The aeration over there, it's not an anaerobic process, it's an aerobic process. But as the water falls from the top to the bottom through a series of plastic mesh, then the bacteria which develops on that mesh, on an increased surface area, that treats the wastewater as it falls down. And air automatically gets sucked. One more minute, madam, but when we try to design the same thing, when we try to implement it for a state like Arunachal Pradesh, which is a high altitude state with low temperatures between 6 to 10 degrees centigrade, we got this area for the waste stabilization pond as about 4 to 5 acres per MLD. Being a hilly state, we could not find any stretch of land, a table land, to accommodate that much of area at one point. So there we have adopted the biotower. Thank you.
Thank you, Dr. Ashfaq. I have a request for you.
Yes, ma'am.
So every time we say that Swachh Bharat is everyone's business, right?
Yes.
So now I would request you to identify a few experts like yourself. And my special request to you is, for the Northeast, we would want one of you, each one of you, different people, to mentor and handhold along with SKPs and other partners who are there, but one mentor for one state in the Northeast so that they will be able to implement properly. So will you be able to find out a resource of like-minded and committed people who can help our Northeast states to design correctly and implement well?
Sure, madam. It's for the country, so
Wonderful.
We are definitely going to try our best.
Thank you so much. We have a provision of mentors in SBM capacity building. Chaurasia ji, I would request you to please take inputs from Dr. Ashfaq, and let's create a pool of resource for the Northeast and Himalayan regions specifically.
Thank you, ma'am.
Dr. Bhala Saab, quickly, your response.
Ma'am, I have added that details in my presentation. I just keep it out. I just want to
So you can share it with everyone.
Yeah.
All right. Over to you, Chaurasia ji. Excellent.
This session is fine. Previous session mein one message was, ma'am, I could not see. That what is the design life that should be for the project. In that case, CPHO view at various forums had been very clear. If you are planning along with network and this treatment plant, you can adopt 15-year that STP capacity and 30-year network as given in manual. The logic behind that STP will be fully utilized. That's why we are allowing, because flow will come from house edge. Where network is not there, in that case we are recommending that STP capacity should be equal to that present one, maybe 2026, because whatever flow is coming, even in that case also present population worth flow will not come. Somewhere going in single pit, double pit, somewhere flow here and there, all flow will not come. So even if you are designing for present, still it will be 30-40% more like we are doing in case of network. But the moment if there is commitment, like in case of Maharashtra, they gave virtually commitment that we have fund, we will be taking up this also. Their STP we allowed for 15-year period, that was only marginally 15-20% higher. So this sort of things we are doing, ma'am. Thank you.
Can I just add one line, ma'am? I was discussing with somebody, see, we have a design life of 30 years. The design life means that if we design for half-filled pipe presently, after 30 years, because of increase in population, increase in organic population, this pipe will get filled up. The pipe का जो structure में damage नहीं होता. You don't have to, in case it is not getting filled up, you don't say that because 30 years हो गया, I need to replace the pipe. A clay pipe life in USA is 100 years. जो हमारे यहाँ पे clay pipe, और हम तो यहाँ पे clay pipe की जगह concrete pipe use करते हैं, और आजकल तो electro steel, more महंगा pipe use करते हैं. So there's no reason for the pipe is not going anywhere because it's well embedded in the ground. So it's only the question of if it gets filled up, तब उसका life खत्म होता, not the structure.
Point I will just add, I have heard it in various forums as observations that CPHO के जो norms है, cost norms है, वो हमारे लिए adequate नहीं है. And I've heard that in solid waste management as well as used water management. Now the point that I would like to emphasize that when CPHO prepared these cost standards, that was way back in 2019-20, all right? It was while 2.0 was being conceptualized. And they did a fair job of collecting the rates from various sources. And primarily, the cost, as is indicated to you, is very indicative cost primarily to arrive at the central share for a state. Your market-derived tender cost will be very different. It is very, very natural. The cost in Karnataka and the cost in Mizoram are not going to be same. So when you take your proposals to your SHPC, your SLTC, please see that you do not create a hindrance in implementation taking the pretext कि इसमें तो CPHO ने ऐसा norm कर दिया, बड़ा defective है, उसमें कोई काम नहीं हो सकता. Please go ahead to discover your own tender cost. Our costs indicate the capping of central financial assistance to a state. Rest, market is the deciding factor.
I request all the panelists to step forward for a photograph. I first request Dr. S.M. Subhani, MD, NCPE, to kindly receive his memento from Dr. V.K. Chaurasia. A round of applause for all our panelists, please. Thank you so much. We now move on to session 7. Again, we are not breaking for tea, but there is a running tea being provided at the rear of the hall for those who want it. Session 7 on project financing, recycle and reuse. I first invite our speakers, Ms. Sujata Sri Kumar, Finance Advisor, USAID WashFin Activity. Shri Naveen Saini, Water and Wastewater Management Expert, Gujarat Urban Development Mission. Shri Faraz Ahmad, Deputy Program Manager, CSE. I invite you all to the dais. To moderate this session, I invite Shri Rohit Kakkar, Deputy. To moderate this session, I request Shri Satish Kumar, CPHEO, to kindly join the panelists.
Very good evening, everyone. So I welcome you for the last session. So this session, from the morning you would have listened about the planning, implementation and technology selection and everything. So this session is actually the most important aspect of any project, that is financing. And in addition to that, to top that cherry on the cake top, we are having this recycle and reuse also. So here we have three speakers, three eminent speakers from different agencies. This is actually a last session. Being a last session, it is very tough. So time constraint is also there, and we are running behind the time. So I request all the speakers to make their presentation within 6 minutes time. I'm very sorry for that one because many of the people, they have to catch their flights and all those things. With this, I'll directly invite the first presenter, Ms. Sujata Sri Kumar. She is the financial advisor from USAID WashFin Activity. Her topic is preparing bankable projects for used water management, sharing experience from Indian cities. Ms. Sujata, please.
Speaker at the last panel, and that too when everybody has to catch flights, I'll be very, very brief. What is project financial viability? Financial viability means project has the capacity to cover O&M costs through revenue sources, and those revenues leave a surplus after meeting O&M costs to recover capital costs over a period of time. So the payback period is defined as a period during which, So this is viability. Many urban projects, as all of us are aware, do not generate adequate revenues. It does not mean urban projects cannot get financed. That is where the concept of bankability comes in. Projects per se may not be viable, revenues may not be adequate to cover all aspects. All our reform agenda through Ministry of Housing and Urban Affairs encourages cities to design projects which at least cover O&M costs. Our experience in this, barring a few stray cities, is not very great. Particularly in the case of the sewage sector, the used water segment, where either sewage taxes or sewage charges are typically, sewage taxes are clubbed with property tax, and sewage charges are a minuscule amount of water taxes. So the viability issue remains in the sector, but that doesn't mean you cannot improve bankability. I have a few examples. A brief introduction to the WashFin project. Basically, the WashFin project aims to provide the financing angle to water and sanitation and hygiene projects. The objective is to mobilize resources and demonstrate that if you prepare projects properly and you do your upstream preparation well, then it is possible to raise finances from the capital markets, from the banking channels, multiple sources. Like a speaker mentioned in the morning, in India today, funding is not an issue. You need bankable projects, you need well-structured projects. That is the key to achieving financial closure and achieving objectives. There are limits to which, grants from Government of India, grants from states can meet, the demand for project funding. It has to be through multiple sources. You need to have a blended financing approach, grants, borrowings, other sources, user charges, PPPs where feasible. A few examples, just 3 today because there's a paucity of time. The important concept here is creditworthiness. What is creditworthiness? At a very basic level, it means the project entity or the city has capacity when it borrows money to pay interest on time as agreed with the lender or investor and to repay principal on the due days. So the principal has to be returned after a period of time, and periodically a fixed interest rate or a variable interest rate, as some banks charge, has to be paid. This is the concept of creditworthiness. At a more fundamental level, creditworthiness means improved governance, improved financial management, and improved operations. All these three in any project in any ULB is what translates ultimately to creditworthiness. Moving on to the next slide. Yeah. Experience with PPPs in the wastewater sector. Just one example. The slightly older project, a 2015 project of Mahagenco. Why is this important? This gives an example in terms of this, wastewater, reuse of wastewater, how can it make it viable? In the case of Mahagenco, wherever in cities you have a large user who can absorb the wastewater, be it, say, the Mathura IOC refinery in Mathura, be it this Mahagenco project in Nagpur. Here there's a large off-taker. In this particular project, 50%, it is not that the user is paying all the capital costs and all the O&M costs. The user is Mahagenco, which obviously needs the water. But the financing was worked out in a way to make it acceptable to Mahagenco to use this water instead of alternate sources. The 50% of capital costs were met through grants from JNNURM. 20% was borne by Nagpur Municipal Corporation, 30% by Mahagenco of the capital costs, and the clause was that if there were cost overruns, Mahagenco had to bear them. And over and above that, Mahagenco would pay the ULB a certain amount. I think it's 15 crores per annum on a monthly basis. And any excess treated STP water taken by Mahagenco, it would pay an additional sum of money. This project demonstrates that by choosing wherever in cities such big off-takers are available, this is the approach to make it work. There are other examples in India. I will not go to them. The second example is, of course, what a co-speaker from an earlier panel from NMCG mentioned. NMCG has, taken the hybrid annuity model used in roads and used it for the wastewater sector. From a financing perspective, the key plus point for an NMCG project is that annuity payments are coming from Government of India. Typically, if annuity payments come from a ULB, there are a lot of payment issues, And that is what ends up that the bidder loads those costs, the delayed payments, the working capital financing required for that, whatever all that is. So the project cost, you may have a certain estimate at the time of tender based on BOQs or whatever and your, schedule of rates. Actually, when it goes to tender, the costs are much, much higher because the bidder factors all these risks in. There's definitely a need at the national level to work out a way to address, payment issues by ULBs. It is working very successfully in the case of bond issues because this entire framework is put in place. This is not I have an example of a bond issue from Ghaziabad Municipal Corporation, which will move on next. There is this example I gave you of Mahagenco where 50% grants came from Government of India and partly from the state and then, of course, Nagpur. The other approaches today, both Amrut and SBM projects are providing grants. So cities can use that, contribute something themselves, look at PPPs where there is either a market for the used water, for the treated wastewater, dyeing units, etc. And Saibabad industrial area who are abstracting groundwater, polluting the groundwater. And there was a lot of strictures against them from the UP Pollution Control Board. So they approached the municipal corporation for clean water to use for the... So that is where this concept of reuse of STP treated water came up for Ghaziabad. There was already a STP for secondary treatment. Then this whole project was about setting up a 40 MLD TTRO to supply industrial grade water to, textile cluster in Saibabad industrial area. The way the original financing was looked at was that 150 crores would be raised through municipal bonds. Because of the incentive available under Amrut, the cost at which these bonds were raised were 8.25. Government of India was offering 13 crores as incentive for every 100 crores raised. So the cost came out about 6.75%. These 150 crores was being supported through property tax revenues of Ghaziabad Municipal Corporation. They had some property tax increases to make sure that debt servicing were comfortable. They maintained their rating. They had a AASO rating acceptable to the market. So the initial capital cost for the project came through the municipal bonds. The original estimate for the project was about 240, 260 odd crores, which they thought that balance 100 odd crores they would meet through internal accruals and they would do the project on EPC basis. Later discussions with Mahua, feedback, etc., because there were industrial users willing to pay for the water, they said, why not look at a PPP model? That's when the hybrid annuity model was considered. Project was bid out. VA Tech Bagh won the project. For the reasons I mentioned earlier, and maybe cost escalations between when the project report was prepared and when actually it was tendered, the tendered project cost turned out about 300 odd crores. And sorry, I'm just finishing. And the way the project works is 150 crores is met through property taxes and recovery of this, whatever this money, 150 odd crores, 170 odd crores, which is being put by the private operator, which is VA Tech Babad, that recovery is happening through annuity payments. The city's liability for annuity payments are being met through user charges recovered from industrial consumers. There will be a payback. Once it's a 15-year concession period. So once the annuity is paid, after that, whatever is recovered, the city can use to recover as capital investments. Thank you. And I just wanted to highlight that we are a part of USAID. It's a finance team available with us. Any city, any mission director, and any state needs support in financing projects, raising municipal bonds. Also, cluster of projects from small cities can raise, pooled municipal bonds. We are available to support you. Thank you.
Thank you, Ms. Sujata. Your points on this creditworthiness, as well as the Nagpur model, NMCG model, as well as this Ghaziabad green bonds, it has been well taken. Thank you for your wonderful presentation. Now I will call upon the next presenter. The next two presentations is on recycle and reuse. So the first presenter on recycle and reuse will be Mr. Naveen Saini. He is a water and wastewater management expert from GUDM, Gujarat. Over to you, Mr. Saini.
Thank you very much. Good evening all. So I'll be discussing about reuse of treated wastewater in state of Gujarat. Ma'am just highlighted that operation and maintenance of all the assets is one of the key issues that we are facing right now. So in my session, I would be discussing about the Gujarat status as of now, how much reuse we are doing. Then Gujarat has a policy on treated wastewater reuse. Then we have the policy mandates reuse in certain sectors that I will discuss. Then reuse scenario, like what is the percentage right now being used. Then we are having an RFP which is right now online for hiring of an agency. What are the parameters used and what are the key challenges and opportunities that we have in reuse of treated wastewater. So right now, if you could see, Gujarat is generating 4638 MLD of wastewater, and we have already got installed capacity of 5692. To add on to that, the capacity utilizes 4107 MLD, which is a very high number, which right now after treatment goes either into the natural streams or in the rivers. Out of that 4107, we have already started reusing 1206 MLD of wastewater, which is treated into various uses like industry, agriculture and all. We have got projects planned for 1272 MLD. The infrastructure of treatment in Gujarat is it is very, very big infrastructure right now. We have got 204 STP of capacity, 5692 MLD. There are almost 48 STPs which are under construction and which will be completed by December 26-25, and there are various which will come. There are 2 STPs which would go up to 27. So talking about the policy on treated wastewater reuse. So the policy mandates that the reuse should be there and the priority should be thermal power plant, industry, and then other usages. There is one change in this presentation. As on 19th of November, that was yesterday, there was one GR that was issued from government of Gujarat, which mandated that there won't be any reuse of raw sewage. And another, the secondary treated water at STP outlet will be at 20% of prevailing freshwater cost. Now, these are the, like, when we talk about costing, so the costing factor, there are various factors which affect the costing. The factors like where we are going to supply water till, for example, STP lies at X corner and the industry lies at Y corner. If I'm going to supply water till the gate of industry, there will be a different cost. If I'm going to supply water till the gate of, let's say, industrial estate, then there will be a different cost. If the industry itself make an investment to get water from the STP, then there will be a different cost. So those financial arrangements are also discussed into the policy. When we talk about policy objectives, 70% of reuse wastewater by December 2025, reuse of 25% of fresh water consumed. That is a very big, that will save us 25% of fresh water which is currently being consumed and which will be available for drinking also. And policy mandates that we will be reusing 100% of treated wastewater by 2030. Now talking about in which areas we can use these use the treated wastewater. So these are non-potable areas. The first one is thermal power plant. If any thermal power plant lies in the area like 50 kilometer vicinity of STP, then first priority should be given to thermal power plant. Then industrial unit, construction activities, commercial institutional users if they are using it for flushing and other purposes. Then municipal uses, municipal corporation uses water for gardening and other purposes. In the morning when we were coming here, we saw that there was a truck which was moving ahead of us and dropping water on the road, so there is no dust. So that kind of uses can be there. Other non-potable uses, then the last one is agriculture. Although the policy mandates that the agriculture usage should be the least prioritized, but it is the most used right now. Okay, so presently this is the scenario. When we talk about municipal corporations, 61% goes into industry, 4% goes for irrigation purposes, and 34% goes for gardening purposes. And when we talk about Nagar Palikas, maximum usage goes for irrigation purposes and gardening purposes only, because that is one of the places where Nagar Palika themselves uses these water. Okay, I have taken two of the case studies here. One is of Surat Municipal Corporation. So they are already having 3 operational projects of reuse, and they are generating 12.5 crore per month revenue from that. Another one is Gandhidham Anjar Nagar Palika, where the capex was borne by Welspun India Private Limited, and they are operating it also, and they are just out of all the revenue generated from that, they are sharing 37 lakh per month with the Nagar Palika. So these are the two case studies which I have presented here. So like, if it can be possible in a Nagar Palika, it can be done in other Nagar Palikas also. Keeping that in mind, there are 159 Nagar Palikas in Gujarat. So keeping that in mind, we have formulated one RFP where we will be hiring an agency who will be like identifying the projects and who will be creating a master plan for identification of these treated wastewater projects. So quickly, this will be their scope. So starting whenever they will be onboarded, they are going to do a need and assessment planning. There will be infrastructure evaluation, like what is the age of the infrastructure, what is the age of STP right now, for how long it will be operational, as we talk about the life cycle also. Then they will carry out the technical studies like XYZ industry needs some water, what are the parameters that they need water for. Then there will be financial analysis, which is a major part. Right now, in absence of this agency, we have received almost 20 odd DPRs from which are prepared by Nagarpalika themselves for reuse. GODM mandated that all the Nagarpalika have to submit one DPR each for their existing STPs. But one thing was missing was the financial analysis. We wanted those projects to generate some revenue so that it can at least bear the cost of operation and maintenance of the asset. So financial analysis is one of the major scope that we have given to the agency. Then we have also kept stakeholder consultation also. Deliverables contain the inception report, that will be just the methodology, how they are going to do the work. Then there will be an interim feasibility report, there will be a final feasibility report, and after that support and parallel activities will also be there. In addition to this, there is a discussion which is going on parallel in the offices that that agency will be preparing the DPR and DTP also, and will carry out the PMC work also. So the deliverables and scope are going to increase. So what are the expected outcomes that we are thinking? So there will be the agencies will be selected for each RCM zone. As one of my colleague Pranav explained that there are 6 RCM zones, so there will be 3 agencies handling 2 RCM zones each. There will be feasibility, block cost analysis also there, rate finalization, and they will also do the draft MOU and agreement with the stakeholders.
Mr. Saini, can you please wrap it up? Can you please wrap it up? Time is up.
Yeah, this is the last slide. Okay, so this is the last one. This is the last slide where I'll be discussing about the key challenges and opportunities. So the first challenge is wastewater management. What are we going to do of the wastewater? So that challenge will be addressed using this reuse. The groundwater. One of the key challenges that we are facing right now is there is a lot of groundwater which is available, so people are not ready to take the reused water. Competitive pricing of water. Yes, the policy is dynamic, so we are changing we are updating all the prices as we go ahead. Then there are opportunity of revenue generation which will address the O&M of the asset. Obviously there will be a reuse, and the industries will have a sustainable practices. Thank you very much.
Thank you, Mr. Saini, for your presentation on your Gujarat government's policy on treated wastewater, recycle and reuse, as well as RFP for hiring the agency. Next, I'll invite the last speaker of the day as well as for the workshop, Mr. Faraz Ahmad, Deputy Project Manager from CSC, to talk about reuse of treated sewage by various cities. Mr.
So good evening, everyone. So as everyone said, this is the last session, and it's very rightly last session because in this I am going to present a study that has been conducted by CSC, which we have taken in 7 states of India, 4 states in northern India, and 3 states in southern part of India. So this study that we have taken is just to analyze that how different states are faring in terms of reusing of treated wastewater, what are their policies, and how the things are implemented on ground in the real scenario. So the session outline will be current wastewater scenario, then brief about CSC study, and I'm not going to present the case study because a lot of case studies we have collected and documented and analyzed throughout this country. But due to time constraint, I am not going to delve into the case studies. Then key highlights from the study and what are the recommendations that we need to look into to scale up this reuse initiatives. So very quickly, if we see the current wastewater scenario in India as per CPCB 2021 report, So sewage generation in the urban context it is 72,368 MLD. And if we see the installed sewage capacity, it is close to 32,000 MLD. And out of that, operational sewage treatment capacity is 26. So there's clear gap still between the sewage generation and the sewage treatment that is happening. And over the years, various policies and institutional framework has been developed to scale up these reuse initiatives. If you can see, and very latest, we have like 2022 National Framework on Safe Reuse of Treated Wastewater, which has been released by NMCG, and in which all the aspects of how to scale up the reuse in terms of prioritization, in terms of stakeholder mapping, financing, and everything has been mentioned, which can act as a guide for states and ULBs to promote this reuse initiative. And in this, national target has also been set up. So where STPs are operational, 50% of that water to be collected, treated, and reused by 2035, and all 100% by 2030. And where STPs are not operational or does not exist, so they are 50% by 2035 and 100% by 2030. So because all these policies and everything we have been hearing all day, and it can be available also. So due to time constraint, I'm directly jumping to CSC study and what methodology we have adopted. So if you can see, we have conducted this study in 7 states of India, and the state has been selected where some most significant case studies we could find. And the study analyzes the not only the national level policies and programs, but how states have their own policies and how they are faring in terms of implementing projects on ground and taking up the reuse of treated wastewater. And this study only concentrates on treated used water from centralized treatment facilities. And the analysis, the findings, and the recommendations that have been given in this study is based on the assessment of 35 case studies that have been collected from 7 cities across 7 states in northern and southern India. So the key highlights, if you see, for all the states we visited, we mapped what is the total amount of, what is the number of STP they have, what is the total amount of wastewater that is being generated in every state, and most importantly, what is the percentage of treated wastewater that is being reused in this state. So if you can see, Haryana, it is 15%, 49% in Delhi, 29% in Rajasthan, similarly Karnataka, 43%, 17% Tamil Nadu, and 17% in Maharashtra. And Delhi, it is showing higher just because 265 mgd of treated wastewater Delhi has to discharge in Yamuna as per the mandate of Honorable Supreme Court of India. So they are also taking that as a reuse, so hence the number is high in Delhi. And what we found in all the state, that major reuse that is happening, if you look at the sectoral wise, so major reuse is happening in agriculture, which is 40%, followed by lake revival or lake rejuvenation, which is 26%, and then industry, which is 20%. So some of the key highlights from the state, if you see, Haryana basically is faring good, and they have integrated water resource action plan, where they have like complete detailed plan from 2023 to 2025, and these plans are being continuously monitored month by month for every block and district, and what interventions they are doing and how they are completing their task. In Delhi, there is draft policy in 2016 which promotes the decentralized use of treated wastewater with set targets. However, faster policy adoption and implementation are needed for achieving targets. And action plan and policy exist, but as of now, still clear implementation strategies lacking in Delhi in terms of reuse. Rajasthan, treated water is primary practice in industries. So in Rajasthan, as we know, it's a drought-prone state. So the risk is that it doesn't lead to industrial monopolization, and reuse should be prioritized based on equity and justice, because there are many places where even we have shortage of drinking water. So there we have to see how we have to prioritize this treated wastewater as per the area-specific requirement and need. Uttar Pradesh, as of now, no mandated policy or action plan when we have conducted this study. And treated wastewater is used mainly in agriculture, because in Uttar Pradesh we have canal-based irrigation system. but it is mostly unplanned through canal system. So proper monitoring how much water is being delivered for agriculture, what is the quality of water that the farmers are taking. So these things are not monitored. And since accessibility to groundwater is very easy, there is no stringent, you can say strict norms of extracting groundwater, and anybody can take, just dig up well and take groundwater. So these conditions basically hampers the scale up of treated wastewater reuse. In Karnataka, Bangalore holds 50% of state sewage treatment capacity and offering the highest reuse potential. And most reuse is happening for lake revival and aquifer recharge. And some decentralized system are also provided where wastewater is treated and being reused for parks, garden and industry. Tamil Nadu also action plan and timeline as of now is clearly missing, and major reuse is happening only in Chennai. And there it is mostly promoting the tertiary treatment of water and for industrial reuse. And so in all this, in Maharashtra, in Maharashtra also major reuse is very concentrated in like cities like Nagpur, Pune, Mumbai with limited adoption elsewhere. So what we have seen, so these are some of the snaps that you can see that we have captured during our visit. So where you can see wastewater being used for construction, irrigation, shallow aquifer recharge, canal irrigation, and revival of lakes. So what we have found in our study that still the major reuse in all this state is confined to only 2-3 major cities. It is not equitably distributed across the state. Be it in case of Haryana, be it in case of Karnataka, be it in case of Rajasthan. So all states we have seen. So what is recommendations is that still only 17% of the total treatment capacity complies with the established standards. So infrastructure revival in terms of how each STPs are complying with the treatment standard of reuse. And as of now, absence of reuse standard for a major hurdle towards reusing of treated water. And standard of reuse should be tailored to a specific purpose of reuse, not a one-size-fits-all solution. Then only limited number of states had made significant progress. So as I was saying that, like for in Haryana, Gurugram, 50% of total wastewater is generated and reused in only in Gurugram. And in Karnataka, 69% alone is used only in Bengaluru. And need for state level policies developed through public engagement. Then wherever we have this reuse policy in state, a dedicated timeline and action plan needs to be there for monitoring the progress of the project. And then effective governance model needed. Still many states, when we discuss with the stakeholders, so still lack of stakeholder mapping, and the roles needs to be defined properly, who will look into what in terms of reuse initiatives. And local treatment and local reuse should be prioritized. There are many states where we visited, we found that there are huge STPs, 300, 200 MLD, but the demand centers nearby are missing where they can reuse this water. So they have only left with the option where they have to convey the water like to 100, 150 kilometers to make the reuse happen. So we have to prioritize local treatment and local reuse. And CSC roles, so we have been working in different areas of reuse. So this is the report that we are going to launch hopefully the next month, Waste to Worth, managing India's urban water crisis. Then we are also working in Uttar Pradesh, where we are preparing guidance note for prioritization on reuse of treated wastewater. And then we have recently released our city level template for reuse of treated wastewater, which has been released in Ganga Utsav. So this is CSC's work in reuse of treated wastewater. So thank you so much for your patience here.
Thank you very much, Mr. Faraz. I guess your presentation will be benefited in two ways. One is actually they would have these states, whatever the 7 states which you have conducted the study, they will be, you are very clearly pointed out where are the gaps that is lying and how to proceed and all those things. In addition to that, in your report you have pointed out that around 60 to 70% of water is being used for agriculture and lake regeneration only. So accordingly, the engineers as well as the administrator over here, they will be selecting their treatment processes. And moreover, these things, whatever they have conducted, These studies has been conducted in cities, not in the towns. But here under SBM, actually these things, whatever we are focusing in SBM 2.0 are smaller towns comparatively. So that is the thing actually, you have to judiciously, you have to take the treatment technologies. With this, we have come to the end of the presentation. So we will be opening right now for the questions. We will take 2 questions due to the paucity of time. If there is any questions, you may please ask. Yes, can you please someone use the mic? Yeah.
Yeah, it's audible, it's audible. Good evening, everyone. My name is Lakshmikant Tripathi. I am the Executive Engineer from Odisha Water Supply and Sewerage Board. My question is that why we don't charge to the Water Resource Department? Because most of our STP, they contribute water to the rivers. And many of the industries and the municipality on the downstream, they get water from the downstream of the rivers. So if we will charge some amount of rupees to the Water Resource Department, so it will contribute to a circular economy.
Can you just direct the question? To whom you are directing the question?
To Gujarat, actually.
Gujarat. Mr. Saini, can you please answer?
If I'm getting your question right, you are saying that supplying the reused treated wastewater to the river or putting it into a canal, and you want that to be charged from the water supply and whatever.
Water Resource Department.
Water Resource Department.
Because all the water bodies. Because most of Water Resource Department is the nodal agency to distribute water in the state, right? So we also, in PSD, we pay money to withdraw water from the river. So after treatment, we are recharging the water body, na? So we should get paid for the treatment, na? So there will be a circular economy.
Okay, thank you. It is actually very difficult to quantify that one, and on what basis they have to charge also, it will be very difficult. And moreover, recovering that cost also, it is once again difficult, because you are just letting it into the canal, and you cannot just like that, you cannot charge the farmers. So you have to have a proper recycle. So, but once again, it should be benefited, no sir?
My point is, you were earlier charging polluted water back into the rivers. At least now you are treating and putting it back. They were not charging you or fining you when you were putting the polluted water. So why are you expecting them to pay for treatment?
Okay.
No,
okay, that.
In case there is STP.
No, your question is well taken, but there are some practical difficulties in determining the charges as well as recovering the charges also. So let us go to the next question. Is there any other question? Yes, to the gentleman over there.
Thank you so much. Myself, Deepak Sharma, as Mr. Naveen, I think so from Gujarat, he mentioned that he has floated one RFP. My concern to senior level, you have published the tender. There's a limitation for the small scale industries consultant to bid those projects, because in your RFP you have mentioned minimum turnover should be 30 crore. When individual ULB, your consultancy fees will be maximum 20 to 30 lakhs. So it is my suggestion that we has to give the opportunity to the newcomers who just started their company as a consultant and they want to do some great innovative ideas in the water and wastewater sector. So it is my humble request to every department, whenever they are floating a tender, they should consider MSME companies, so their innovative ideas, because youngsters, they are having a brilliant idea to implement, like artificial intelligence, machine learning. Now it is upcoming field in water and wastewater sector. So it is my humble request to every department, whenever you are putting a tender, at least you give us some leverage to MSME companies so they can also participate. They also technically qualify. Like I am doing so many projects in MP for the Swachh Bharat Mission. I think so in MP, my company is the first company who prepared and delivered the DPR and float the tender. And rest company they never did. But my company is the MSME, we don't have a turnover. So it is my humble request, like whenever you are floating a tender, consider MSME.
Mr. Saini Menat, do you want to answer that one?
I think Mr. Deepak, right? So there were many, during the pre-bid meeting also, there were many vendors who wanted that. So it is under discussion. At the same time, the state is also in dilemma that whether we should go with experienced one. I think higher authorities can answer that very well. We are always in a dilemma that whether we should go with experienced one. If I'm saying that you should have done, let's say 5 projects of similar nature, you should have done 2 projects of similar nature. And if you have not done any project of that nature, there is always a dilemma with us whether we should hire someone or not. So even when we go for a job interviews, they would ask कि आपने ऐसा काम किया है या नहीं. So
okay.
I mean,
it is actually the.
I'm not talking about the technical capabilities like World Bank, ADB, and Delhi Jal Board. Delhi Jal Board is a big organization. They are having a budget around 10.
Mr. Deepak, you can ask this question after this session because some of them actually they want to catch the flight also.
That is a very important question.
No, that is I can understand, and it is the state government who have to take the call. So you can ask him later, right? So with this, we have come to the conclusion of the session as well as the workshop. Ma'am, if you want to offer any insights, ma'am. To madam.
3 quick observations. First of all, Sujata ji, not now. Sujata ji, it was a pleasure seeing you. Reason being, out of 36 speakers, there were just about, today I think there were 2 lady speakers. So I raise my voice of protest once again, Chaurasia ji, about this gender bias that you have. And next time, Sashank, you're curating the sessions. I would like to see a more balanced. No, mujhe reservation nahi chahiye. I would like to see a more balanced, team there on the stage. Nonetheless, I think you were brilliant in highlighting that point of ham, because people generally kind of prescribe it for all sectors without seeing from where the O&M costs will accrue. So that's a brilliant point made. And I would request USAID, because you're already working with the ministry, let's make a profiling of these feasibility of such cases, including what just Gujarat also mentioned about, and one of it was for a small city. And if we can share these kind of PPP financing models with all the states as a knowledge material, that would be great. The second thing I'd highlight, Sashank was just giving me the data here. This policy of treated wastewater reuse, it's quite fascinating to see that only 11 states in the country have a clear-cut policy of treated wastewater reuse, and that's also what CSC study was trying to highlight. And 3 of them have wastewater reuse incorporated as larger water policies, and the rest of the states have no wastewater policy. So this is where, again, I would request mission directors and state heads to take this as a takeaway from this workshop. We cannot plan in isolation as a SBM urban team for small cities. It has to be a larger overarching plan policy of the state where we are addressing wastewater management, including treatment and reuse. So for all those states, even where you have a policy, please see how your action plan is matching to your policy. Because even CSE study did indicate that even where you have policy, you're not having matching action plans. So my request is, this policy is what you are preparing as your used water management plan. Be it under Amrut, be it under Namami Gange, be it under Swachh Bharat, be it under any external aided funding. So please take a holistic view of it, and it is in SHPC that these kind of issues should be discussed under the chairmanship of the Chief Secretary. The third important point which came out from this forum, this particular session, was again related to reuse. So Chaurasia ji, this committee which is now come in under the chairmanship of the additional secretary, reuse, standards, benchmarking. I think we need to quickly finalize that. What Namami Gange has already issued as a standard framework is a guiding light for us. Using that for sectoral specific, let's prepare it quickly, have it discussed, and let's target January, the beginning of the coming calendar year, if we can have it finalized. Bilkul. Thank you.
Thank you, Madam, for your guiding words. With this, we have officially come to the end of the workshop as well as the session. So,
I request all our panelists to kindly step forward for a group photograph. We request our panel moderator to kindly hand over the mementos to our participants. Thank you, panelists. I now request Dr. Chaurasia to kindly provide concluding remarks for the work we have seen displayed here for the past 2 days.
Thank you very much. So, my thanks and congratulations to all of you for patiently being present, full house here and contributing in discussion. I will not go in all those sessions because that has been discussed in detail, question, answer and all other things are there. Finally, before leaving, I have come to request some of the things and so that when you go back to your home, you are able to provide us. First thing, CPHO is aggregator and helps others who are needy. So wherever best practices are there, anything which you can showcase, please provide to us so that we can guide others. Even many states are eager to see some of the successful projects. So in any of the states successful projects are there, you find it is credible, please share to us. Similarly, whatever issues and challenges are there at state level, please share to us rather than discussing at your own level and thinking that it is workable, it is not workable. Those things should be shared to us. And CPHO will be ready to support at any point of time that we are there. Another thing that Joint Secretary also earlier mentioned, Swachhatam portal pe data populating is very, very important, not only from survection and certification point of view, but from JMP point of view. So I request each one of you senior people to lead this so that data is quickly filled up rather than leaving to that MIS person. This data is very, very important. That should be taken. Similarly, regarding standards, I made a presentation that will be definitely clicking somewhere ki why this sort of confusion is there. I request, since it is a state fund, public fund, State Urban Development Department and State Pollution Control Board both need to discuss and jointly act so that we can utilize available public fund in a more, let us say, better way. Similarly, wherever you are planning, robust system in the mind should be there. Fund is going to come. There is not a problem. It is a matter of implementation in phases. So I request that whenever you are implementing, that long sight also should be there, that we are going to develop it into a robust system. And in no way under pressure or somewhere hurriedly you are utilizing fund and sending UC. That thing should be avoided. Similarly, this one more thing I would like to mention, that is somewhere some type of bankable project in smaller, whether it is for solid waste and liquid, that also please share so that we can circulate to all of that. And finally, one point I would like to mention, that government is working towards circularity in big way. If you have any document, any expertise to support, please share to us, because we want to develop a ecosystem. Even any one of you want to work with CPHO, that is also most welcome. So with this, I thank each one of you. Thank you very much.
Thank you, sir. There are two functionaries here whose rigorous standards have made this year's National Knowledge Workshop very successful. To felicitate them, I invite Shri Anuj Kumar Jha, State Mission Director, Government of Uttar Pradesh, to the stage. I now request Shri Anuj Kumar Jha to kindly hand over a memento of appreciation to Ms. Rupa Mishra, Joint Secretary and MD, Swachh Bharat Mission Urban, Ministry of Housing and Urban Affairs. Please, ma'am.
Just 1 second. Yeah, so I take back the focus on the point from where we started. So we launched the Clean Toilet campaign yesterday, and already Indore takes 1 lakh selfies with CTPTs in 24 hours. So people ask me why Indore is getting the award every time. The fact that the engagement with people is at a level which is quite unparalleled, where community public toilets are seen as truly a place to celebrate, a community place to gather, and that beauty and cleanliness goes and reaches till the CTPTs. So while CTC 2024 rolls out, in the first 24 hours itself, Indore is already here. So for the next 5 weeks, I request that our story and our effort of yesterday and today, you heard 36 experts share various experiences from different parts of the country. You heard for almost 2 hours dignitaries from across, the Honorable Minister from Mahua, the Honorable Ministers from UD Department, Government of UP, the US Ambassador all the way, the partners rallying their effort with the Government of India, all of it for one cause, which is Swachh Bharat. So for the next 5 weeks, toilets, flushing, beyond toilets, this story has to intensify. All the discussion that we've had is around that. From toilets to beyond toilets, and 5 weeks Clean Toilet Campaign 2024, I would request the lead cities of UP at least to take up this challenge, gear up, and Mission Director, I would request you to please immediately start your work around the Clean Toilet Campaign, which perfectly aligns with the Mahakumbh. And I also request all the states to go back immediately, start sharing the guidelines, the 5 to 6 points that we have put together, including the footfall mapping, the data entry, getting ready for the JMP, which is about to come in the next couple of days, the ODF certification that's going to start in a couple of weeks, completing your plan. And as you heard from everyone, the clear timeline that is required for implementation is anything between 15 months to 18 months, which means by 31st March coming year, all your projects must get started. Only then we are possibly getting a clear 15 to 18 months time for completing these projects as per the expected outcomes. But I'm very sure with your commitment, your passion for Swachh Bharat, and your experience, we will be able to reach this goal. All my best wishes to all of you, and thank you to all the hosts and organizers for making this happen. Thank you so much.
For our next memento, I request Shri Indrajit Singh, Municipal Commissioner, Lucknow, to kindly approach the dais. I request him to kindly felicitate Ms. Anita Meena, Director, Ministry of Housing and Urban Affairs. Please, ma'am. Thank you, ma'am. Thank you, sir. I now request Shri Shashanka Velidandla, Director, Government Advisory, Wash Institute, to kindly propose the vote of thanks.
Before it concludes, finally, just one little word that guests who are staying for the night or traveling tomorrow or day after tomorrow, if you want to have any kind of facilitation for going around Lucknow or maybe nearby cities like Ayodhya or any other place, please feel free to contact us through your coordinators, and we'll be happy to help in whatever way to make your stay comfortable and your visits comfortable. Thank you.
Good evening once again. It's my pleasure to propose a vote of thanks at the end of this two-day workshop. First of all, I would like to thank all of you for having participated with gusto, energy, and given your valuable suggestions, questions, visited the exhibition, encouraged us with your words. So a big thank you to all the participants. I would thank ma'am, JS ma'am, Rupa Mishra ma'am, for giving us the energy and the passion. We met her n number of times in the build-up to this workshop, and every time she guided us, gave us a lot of very beautiful suggestions on how to do this. So the design of this workshop, thank you so much, ma'am. Anita Meena ma'am, thank you so much for reaching out to all the partners for helping us to make this a success. The National PMU, where are you? Washai KPMG, I think they had a flight to catch to the left. But thank you to the National PMU for facilitating this in a big way through their boundless energy. None of them slept for a few nights. My distinct pleasure, our guides, Dr. V.K. Chaurasia sir, Rohit Kakkar sir, and Satish ji from CPHEO. They put together, curated each and every technical and non-technical session, went through the slides, gave us real guidance on what the content should be. So thank you so much for your energy and passion, sir. Our co-hosts, the government of UP, right from the Principal Secretary Amrit Abhijat, sir, our Mission Director Anuj Kumar Jha, sir, and Lucknow Municipal Corporation Commissioner Shri Indrajit Singh ji. Thank you so much for helping us put this together. I know it was at very short notice, and we got a lot of support from you. Unstintingly, we asked you many things, and you helped us out without any hesitation in organizing, finding the venue. Many, many things went into this, so thank you very much. We're very grateful to you, sir. We're very grateful to Ma'am Ritu Suhas ji. She has been behind getting so many things done here, including the mementos and the small, small details that go into making this thing happen. Thank you so much, ma'am. The PMU Suvasi team at UP, if you are here, please, thank you so much. Yeah, Kamaljeet Singh, sir, Chief Engineer UP, thank you so much, sir, for supporting us and guiding us through this. Many, many people here in UP have supported us, including the Lucknow Development Authority officials, police officials. We're very grateful to you. It was, as an NGO, we find it very difficult to handle protocol and things like that. It's not something that we understand very well. Your guidance in that aspect is deeply appreciated. I also wish to thank our event partners for they set up this event in 3 days flat. It was very grateful to them for doing that. Digital Jalebi, Harshit and his team, and Moksh Events. Thank you so much. And a very important gratitude goes to our donors, the USAID and the Bill and Melinda Gates Foundation. This year, they participated in a very big way. The Honorable Ambassador of the US to India also participated this year. We are thankful to both USAID and BMGF for supporting this event and making it happen. This is the 3rd year that they have supported us. Very grateful to them. Last but not the least, my team. If you're here, please stand up. This team has put this together, and I hope you've all had a good time in the last 2 days and also learned a lot. So the entire exhibition that you see, the data for that was collected by this team. They also put up the panels and everything that goes along with this workshop. So very grateful to them also. Like I said, none of this would have been possible without all of you. So very grateful for the participation and for the enthusiastic support. With that, I thank you all very much. This is Wash Institute.
Thank you so much, sir. We now conclude with day 2 of the National Knowledge Workshop. Thank you all for your participation. Have a good day. It's a little ironic that we are mentioning it now, but any participants who have not registered attendance for day 2, kindly proceed to the registration counter and get your QR code scanned. Thank you. Anyone who would like to visit certain spots in Lucknow, kindly reach out to the WashEye team and we may be able to help you coordinate it. Thank you.